Hello, ladies and gentlemen, and thank you for listening to Mr. Laxon's video on these Algebra 2 Section 7.1 notes. Alright, today we're going to look at rational exponents, and really we've talked about this before in class, is that rational is any number that can be written as a fraction. Be written as a fraction. Alright, so that's really what we're looking at today. We're looking at exponents that can be written as fractions. And the main thing today, my essential question is, how do I solve equations using rational exponents? Alright, perfect. So that's my main thing that we're going to talk about today. Some vocab words that didn't really copy off very good. This is index, and this is radicand, and this is the radical sign that should be in here. So the index is always that number that comes in front of that square root. So in the past, we've always looked at just like the square root of 16, which is plus or minus 4. Alright, and then this number that's kind of hanging out there is a 2 if we don't write it. Alright, so that's kind of the deal there, is that index, now we're looking at indexes today that are going to be like x to the fourths, x to the thirds, different things like that. Alright, so if we look down here at these real nth roots, it says if n is an odd number and then a has one real root. Okay, so if we have like the cube root of negative 27, okay, we have an n is odd, my 3 is odd, and then we know that we have one real root. Alright, so the cube root of negative 27 is not plus or minus, it's just going to be minus because this is a negative here. And the cube root of 27 is 3. Okay, so I gave you guys that gold sheet in class, that gold third sheet with all the perfect cubes, perfect fourths, different things like that. So please use that to help you here. Alright, so now if we go on, if n is even and a is greater than 0, you have two real roots. So that's kind of like the example we talked about already. Let's look at like the square root of 25. Okay, the square root of 25 is 5, but it's also plus and minus 5 is where you get those two answers. Alright, so if n is even and a is equal to 0, so like let's say we have the fourth root of 0, the fourth root of 0 is just going to be 0, it's one real root. Alright, so in the last one here, if n is even and a is less than 0, you have no real roots. So that's like if we have the square root of negative 9, okay, and we talked about this a couple chapters before, the square root of this negative number, we're going to break out that I, that square root of negative 1, which is I, and then we still have the square root of 9 left, which is plus or minus 3. So you don't get any real roots, you just have these imaginary roots here. Alright, so that's going to be key today. You have to know which ones are plus or the minus and which ones aren't plus or the minus. Perfect. So let's keep going on here. Let's look at these examples. The real nth roots. So you have to look at the square root of 100. Is that a nice number? So you can look at those perfect squares in that row there and see that, hey, 100 is a perfect square and it's plus or minus 10 because this is even, so you do have the plus or the minus. All right. Even means plus or minus. This guy is cube, so I know that I'm just going to have one answer. It's an odd. Alright, and the cube root of 8 is 2, so negative 2 times negative 2 times negative 2 gives me negative 8. Alright, so the sixth root of 0, that's an easy one. Sixth root of 0 is this 0. 0 times 0 times 0 times 0, 6 times is 0. Alright, don't worry about this fourth one. We're going to cross that one off for now. That gets into some imaginary stuff that we're not going to worry about right now. Alright, so please do me a favor here and highlight this in. You make sure that you highlight in the left side and then the right side as well. Okay, because this rule, notice here that this n in my radical form, this is the radical form, and then this is exponent form. So throughout this chapter, we're going to be going back and forth from radical form to exponent form. And you have to know where these things go. Alright, so this n, this index here, goes in the denominator of my exponent form. And the number that's outside here, my m, goes in the numerator. So notice that, and obviously those a's just stay the same. All right, so if we scroll over here to the next page, notes 114, that says evaluate these guys. So these are in exponent form right now. So this is in exponent form. You need to move it to that radical form. All right. So if it's in exponent form, I know that I'm going to have some sort of radical, and I know that that 16 goes under there, that big number goes under there. This 2 is the denominator. That's the one that goes out in front with that rule, and then the 5 goes outside. Okay, and the nice thing about when you move this from exponent to radical form, you're going to notice some things that you can do here. Like we can take the square root of 16. The square root of 16 is plus or minus 4. And then I can take that to the 5th power. So plus or minus 4 to the 5th power is, if I look here at my notes, you can plug it into your calculator, is 1024. All right, awesome. So now again for number 2, we go, hey, we got to move this into radical form. So I'm going to have some sort of radical. I'm going to have 64 under there. All right, and the 3 is the thing that comes out here, and then the negative 2 comes on top to the right there. All right, so the cube root of 64 is, if you look on your sheet for you, is 4, and then we still have the negative 2 power. Remember here, this is odd, so it's only the positive 4. You don't have the plus or the minus here. So now we talked about this in the beginning of the end of last semester, I believe, is that 4 to the negative 2 power, that goes to the bottom and becomes positive, so 1 over 4 squared, and 1 over 4 squared is 1 over 16. All right, so that's what you get for an answer there. All right, perfect. So here we go, writing these guys. So now these guys are in radical form, and we have to move them to the exponent form. And then it says here, hey, you can just toss in your calculator to find out what you get for an answer here. All right, awesome. So here we have 1700. I know that's going to be my big number, and I have to raise it to some exponent. And I know that this 5 goes into the denominator, but you have to ask yourself, what number is out here if it isn't there? It's a 1. So I have 1700 to the 1/5. All right, and the way that you need to put this in your calculator, you need to go 1700, raise, so that's that caret button, parenthesis 1 divided by 5. Do not forget the parentheses. The parentheses are huge. All right, so if you put this in your calculator, you should get 4.428, I believe. I think the 7 rounds up to an 8 there. So give me 3 decimals. That'd be good. That's what the ACT is going to ask you for. Different things like that. Make this into a plus here. I don't think that copied off anyways. This should be a plus. So that's a 1 there. So now I have 10 to the 1/2 power. So I put that into my calculator. I have 3.162. All right, awesome. Now this last one, you put 1000 to the 5/6. So the 6th is the number that's out in front, so that goes in the denominator, and the 5 goes on the up top. So 1000 to the 5/6 is going to be 316.228 is what it simplifies to. And you have to look here is that this guy is a 6th root, so this is plus or minus, and then also this one over here is the square root, so this one's also plus or minus. Okay, don't forget about those plus or minuses. All right, so now these are the actual solving ones here, is where we have to go through and solve. And the main thing that you see right here is to solve an equation that has x to the n, you need to isolate the power and then take the nth root of both sides. Okay, so we're going to take the nth root of both sides in the end here. But in order to isolate the power for this first one, I got to divide by this 6. So now I have x to the 4th is equal to 625. All right. Awesome. So now here's really the new part, is when I have x to the 4th, to get that out of there, I don't take the square root, I take the 4th root. So now I take the 4th root of both sides, so this 4 cancels out with this 4. I'm just left with x equals the 4th root of 625, and you guys can look into your you first of all look into that gold sheet and say, hey, is 625 a perfect 4th? And you can see, hey, it is. And it's actually plus or minus 5. And it's plus or minus because that 4 is even. All right, number 2, we go through here, and I notice that, hey, isolate the power. Everything over here is being raised to that 3rd power. Okay, so to get that 3rd power out of there, I can automatically just take the cube root of both sides here. Okay, so now I have x plus 1 on that left side is equal to the cube root of 18. Okay, and you can ask yourself, is 18 a perfect cube? So you can look over on your perfect cubes rows, and 18 is not there. So you can, for now, let's just leave it as what we got. All right, so now I subtract the 1, I subtract the 1, x equals, and remember I like to put this -1 first, and then it's not plus or minus because this is odd, right? So it's just plus the cube root of 18. All right, and if you left this as an answer here, that's fine. But your homework and things like that is asking you to give it to you for 3 decimals. So let's put this in our calculator. You can go x equals -1 plus, and then this right here is going to be 18 to the 1/3 power. Okay, so you can put that right into your calculator, and you should get out that x is equal to 1.621 here. All right, just one answer, cube root there. All right, awesome. For number 3, to finish this off, you have to look here. This negative is kind of hanging out in front of there, so I got to divide it to the other side and get it out of there. I have x to the 7th equals -40. All right, now to get that 7th out of there, we take the 7th root of both sides. So I take the 7th root. Those guys cancel out. I get x is equal to, and then now you can look, is 40 a perfect 7th? No, it's not. So now we can just put this in our guy in our calculator, and we put it in there as 40 to the 1/7, because there's kind of like a 1 hanging out up there, right? Put that in your calculator. You should get -1.694 for an answer there. Awesome. All right, so thank you for listening to Mr. Laxton's video on these rational exponents. Please come find me if you have any questions. Thank you.